evaluating trig functions based on a right triangle. So when we're getting going on this, it's very important that we label our triangle based on whichever angle we're really focused on. So draw a triangle, make sure you know I'm looking right here at T being our angle. That allows us to label the opposite side and the adjacent side. The hypotenuse is always going to be across from the right angle. And it's very important that each one of these triangles has a right angle so that we can use this. So the first thing to notice is that we set up sine, cosine, and tangent. Sine, cosine, and tangent first. And we use SohCahToa as a nice way to remember exactly where these come from. So SohCahToa, what that means is sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now the other thing to notice on this is we want to find secant, cosecant, and cotangent. Well, these are reciprocal identities. So whenever you have sine, starting with an S, it's going to get paired up with cosecant, which starts with a C. All right, so a pair of S and C always goes together. Cosine starts with a C, it goes with secant, which starts with an S. And then tangent and cotangent, those are pretty easy to remember typically, that cotangent and tangent tend to go hand in hand. All right, what we mean by reciprocal identity is what you do is you can set up this ratio, this fraction, but for sine, it's opposite over hypotenuse. For cosecant, you flip that upside down. You invert the numerator and denominator, so you get hypotenuse over opposite. So let's jump into an example here. We want to get down SohCahToa definitely as we go through these. So in getting moving in the right direction on this, we're looking at this triangle where we have alpha, and it's 8, 15, and 17 for our side lengths on this. Let's go ahead and label this to get started. We're going to say that 8 is going to be the opposite from where our angle is. 15 would be the adjacent, and then 17 is going to be the hypotenuse. So as we get moving the right direction on these label things, it helps out a bunch. So SohCahToa says that sine is opposite over hypotenuse. So as we've labeled them, the opposite is 8. The hypotenuse is going to be 17. Let's go ahead and find cosine and tangent next. Cosine is going to be adjacent over hypotenuse. So adjacent is 15 as we've labeled it over the hypotenuse, which is 17. Then finally, tangent is opposite over adjacent. So in our triangle, it's going to be 8 over 15. All right, now that we have these three primary ones, what we can do is we can get the reciprocal identities as long as we remember there's an S and a C that go hand in hand. So since sine was 8 over 17, it goes hand in hand with cosecant. So all we have to do is use the reciprocal or invert numerator and denominator here. We can get 17 over 8. Secant goes hand in hand with cosine. So we can say the reciprocal there is going to be 17 over 15. And then finally, cotangent goes hand in hand with tangent. Using its reciprocal, we can say 15 over 8. It's a messy looking 8, but basically that's how we're going to do it, is basically find the first three, then use these reciprocal identities to invert them or flip them upside down, and you get the other three, as long as you know the first three using SohCahToa. All right, hope this helps out. Good luck.